Hello everyone, my name is Kerohit and my project teammates are S. Ravindra and CH Ajay. We are from LBRC College, Melavaram. So our project is a smart transmission line protection. So it helps to protect the transmission line from fault conditions, and it also helps to detect the overload and underload conditions in the for transmission line. So the main microcontroller that we are using in our project is STM32F103C8. So, and we are also using various types of sensors to detect the current and voltage values, and we are also using a relay module, and we are also using a OLED display for our project. The current sensor that we are using is ACS712. It's a current sensor and also a voltage sensor that we are using. It's a ZMPT101B voltage sensor. We are also using a OLED display that is a size of 128x64. It also uses I2C. We are also placing a relay module that helps to break the circuit if any overload is detected. And we are also placing a Wi-Fi module so that we can transmit the data to a mobile app, and we are using a ThinkSpeak IoT here. So the load is connected, and the analog pins from the voltage and current sensor are connected to the STM32 Bluetooth board. The power supply is given, and so the supply is not given here yet to the load. So the values that are reading from the sensor from the OLED displays are 0. So we are seeing that voltage value, current value, and the power value. So these are reading 0. So let's try turning on this load, connecting the load. So now we see the load is connected. Here we are using a serial communication. Using UA active 1. So now we will see the voltage value is updated. So now we can see the values of the values are updated in the OLED display. The voltage that is flowing through the load is 228 volts, and the current will be 237 milliamps. The power will be 66. The values are changing continuously. So it helps to monitor the real-time values of the transmission line, and we also integrated it with the ThinkSpeak IoT, and we also developed an so we also developed a channel ID in ThingsView, so that we can view the values in our mobile. So the values are 237 and 228. The voltage value will be 237, and the current will be 228, and so the current value will be 237 milliamps, and the voltage will be 228, and the power will be 50 watts. So with the help of these things, we can also monitor the values in our mobile. So we have also placed a buzzer that will helps to give siren when the overload or overcurrent situations were occurred. So the threshold values that we are given in the code is that if the value of the voltage is less than 50 volts, or if the value of the current is less than 80 volts, the values will be set to 0, so that helps to filter the noise. So if the power value is greater than 150 volts, and voltage value will be greater than 260 volts, and current value should be greater than 800 milliamps, the relay module will operate and disconnect the circuit, and it also helps to gives the buzzer sound, so that we can know that if some fault is occurred in our transmission line. So with the help of this project, we can able to monitor the transmission line health and transmission line current, real-time current flow values, and other values. So let's try by changing the load of the system. So the bulb we have used is a 60 watt bulb. Let's try by replacing it with a 200 watt bulb, and monitor its values. So now we have connected a bulb of 200 volts across the load. So the values are changing in the OLED display. So let's see the values. The current value is increased to nearly 600 milliamps, and the power is also increased to 123 watts. So we know that this bulb consumes a lot of current. So that will be displaying in the OLED display. And if the load current is increased more than 800 milliamps, or if the voltage exceeds to 260 volts, the relay module will operate and disconnect the circuit, and it also gives a buzzer sound. So this is our project, and as I said, we have used a serial communication UART here. The transmission to transmit the signal, we have connected PA9 in the STM32 microcontroller, and to receive the data, we have connected a PA10 pin to connected port A10 pin, and the voltage and current values are given for analog. Voltage and current sensor value pins are connected to analog pins. So, and OLED display is connected to I2C1. So the clock pin is connected to PB port B 6th pin, and data pin is connected to port B 7th pin. So the ADC inputs are given to PA1 and PA2. When PA1 is connected to current sensor and PA2 is connected to the voltage sensor. The output GPIO output pins for the relay and buzzer are connected. The PA2 pin is connected to the relay, and the PA3 connected is PN pin is connected to the buzzer control. So this is our project. Thank you for watching.